please update the counselor or the team member, like you will be getting a call. So please tell me when you will be available for the extra classes. Suppose if you will be requiring extra classes, let's say you need extra classes for the chapters that is upcoming in your exam. So let them know when you'll be available for the extra class, so it can be scheduled on time. Okay, Priyanka. Also, let me tell you everyone that this is 1.5 hour class. Okay, now today we are having a 1.5 hour class. Okay. First of all, let's understand like what are the resources, right? So resource is basically anything that can benefit the humans in any way. Anything that is beneficial to us, that we simply call as resource now, right? Whether it is living resource or whether it is a non-living resource. It's a living thing or a non-living thing. So anything that can be put into use, anything from which we can benefit is a resource, right? That is simply a resource. So anything that can be put to use, anything that provides you value or benefit, you consider this as resource. Now, there could be a wide range of items ranging from natural resources like water and minerals, coal and petroleum, to human-made resources like technology, like tools, right? So that is simply called as resource. Okay, now. So water is a resource, air is a resource, land is a resource, coal, petroleum, different fossil fuels, these are resource. Then man-made resources like roads, buildings, tools, they're also resources. So resource can be categorized as natural resource or man-made resource. We can categorize them as natural or man-made resource. So what is a natural resource? A natural resource is something we can obtain from the nature simply. So wind, air, water, soil, a lot of other things that we take from the water, from the soil. So all of that is natural resource. Then man-made resources. As I said, technology. As we said, like infrastructures, buildings, infrastructures, roads. So these are man-made resources now. So they are not available naturally. We make them, but to make the man-made resources also, you have to depend upon natural resources now. To construct the road, you will depend upon natural resources like rocks, right? Rocks and many other things. Further, we can categorize the resources as inexhaustible and exhaustible. Further, the natural resource, you can categorize them as inexhaustible and exhaustible natural resources. Inexhaustible natural resources are present in abundant quantity, are present in unlimited quantity. Okay, now? Like water. The Earth is called as blue planet, right now? Why do we call Earth as blue planet? What is the reasoning behind this? Yeah.
Since there is
Mhm.
water.
Right. About 71% of the Earth's surface is covered with water now. Namely, that water is basically in the form of oceans, right? And when it is viewed from the space, this vast amount of water makes the planet appear blue. Hence, why the Earth is called as blue planet because of this reason. So it is present in such an abundant quantity that it is not going to get exhausted in the nearby future. So other than that, air, right? And no matter how much you breathe, no matter how much of air the plants take in, it's not going to get exhausted by any of the human activities or by activities done by any other organisms on Earth. So but they are inexhaustible. They are natural, plus they are unlimited in nature. So with the human use or by the animal use, they are not going to get depleted. For many, many millions of years, they are going to remain. So hence they are natural resources, but they are inexhaustible natural resources. Sunlight can also be taken as an example. Okay. Then exhaustible natural resources. So they are limited in nature. Like coal is limited in nature. Petroleum is limited in nature. Wood is limited in nature. Wildlife, forest, natural gas, these are limited in nature. If you were to carelessly use them, if you were to exploit them, right, without considering the fact that they are limited in quantity, so in the next 50 years, in the upcoming 50 years or 100 years, you won't find them anymore. The current rate at which we are using the fossil fuels, you know that the current rate at which we are using coal and petroleum, it is going to last for only few years. Getting it? It is suggested that the present amount of coal reserves, the coal that we have under the earth, it is going to last for few decades. Like it is going to perhaps last for about 100 to 200 years. While as for the petroleum reserves, it is said that the way how we are using petroleum, the way how we are extracting, the rate at which we are extracting the petroleum from the earth, its reserves may last for another 40 years only. Getting it? So we are consuming them at an alarming rate. So they are exhaustible natural resources. So they can get exhausted by human activities and might disappear altogether, or let's take hundreds or thousands of years to replenish. We know that coal or petroleum, they were not formed in a matter of few hours, they're not formed in a matter of few months or years, but they have taken so many thousands and thousands of years, probably millions of years, to form. The coal that you are extracting from the earth today, or the petroleum that you are extracting from today, they were not from about 100 or 200 years ago, but they were from about hundreds to thousands of years ago. Probably coal and petroleum were formed like a 10,000 to millions of years ago. Getting it, guys? Right now? So they were formed over millions of years through the process of the decomposition. Getting it? Now, when the plants, when the alga, when they were buried, right? When they got buried under the oceans, when the plants get buried under the land, so slowly they converted into coal, they slowly converted into petroleum. So this time frame is very large, like this, it's a very big time frame. Given millions of years, it's a very big time. And you cannot imitate the same conditions. Like you cannot prepare the coal and petroleum in labs, right now. So thereby they are exhaustible natural resources. So coal, petroleum, and natural gas, they are exhaustible natural resources. Also, they are called as fossil fuels. Fossil fuels. Now, fossil is basically remains of the organisms that lived many, many hundreds or thousands of years ago. Now. That is called as fossils. And fuel is something that you burn to obtain energy, that you burn to obtain heat and light energy. That is what fuel means now. So coal and petroleum and natural gas, they are together, they are called as fossil fuels. Like they are the dead remains of the organisms that lived in the past, plus we can burn them, we can ignite them to obtain heat and light energy. Hence, they are called as fossil fuels. Okay. Fuels, I just told you that something that can be burned to obtain large amount of heat, and that to obtain large amount of energy, and that energy you can get in the form of heat and light when it will be burned. So all this coal, petroleum, and natural gas, they are fossil fuels. They are fuel. Further, the fuel can be classified into different types based on their state, like coal, firewood, animal dung cakes. Like here in India, animal dung cakes, particularly cow dung cakes, are sold in the villages, particularly. Although they are not a very common type of solid fuel anymore, but still in some villages you might see that the cow dung cakes would be burned for cooking the food. Charcoal, coke, all of these are found in the solid state, right? So they are solid fuels. At the room temperature, they will exist in the solid state. Hence, they are solid fuels. Then petrol, diesel, kerosene, they are liquid fuels now, right? Also, they are volatile, that if you were to leave them open, right? If you don't keep them closed, so after some time, like after a few months or after a few years, they will completely evaporate. Petrol is usually not kept open now. It should be closed, kept into closed bottles. Why? Because it is highly volatile, like it evaporates quickly, although not very fast, but it evaporates faster in comparison to water and some other liquids. So liquid fuels are namely petrol, diesel, and kerosene. These are the most common examples of liquid fuels. Although liquid hydrogen and some other fuels are also there. but they are volatile. Like when you will be burning them, they will produce vapor, and that vapor will burn and produce energy. Is that much clear? Sorry.
Yes, sir.
Then there are fuels that are found in the gaseous state, like natural gas, okay, biogas, compressed natural gas, coal gas. All of these are the fuels that exist in the form of gas or a mixture of gases. Okay. So far we have learned about the resource. What does it mean? What are the different types of resources? So we have learned that resource is anything that can be put to use, right? Anything that can be put into use, anything that provides value or benefit is considered as a resource. It can be a natural resource, or it can be a artificial resource or man-made resource. Further, natural resource can be categorized as exhaustible and inexhaustible natural resources. About the exhaustible natural resources we have learned, coal, petroleum, and natural gas, they are considered as exhaustible natural resource because their resource is limited on Earth. Particularly about the coal, I say that the rate at which we are using it currently, it may last for another 100 to 200 years only. Can last for another 100 to 200 years. And regarding the petroleum, it is being said that it may last for next 40 years only. If we keep on exploiting it at the current rate, if we keep on using it at the current rate. But suppose if we have, meanwhile, if we have developed some uh, alternate energy sources, right now, then then the resources may last for a few more years. So we should be working towards the alternate methods of obtaining energy. Like we already have some examples, some methods like solar plants are there right now, like that. Also, fuel is also categorized as primary fuel or the natural fuels, or secondary or derived fuels. Like solid, in the solid fuel, you have the example of wood, then liquid as the crude oil. Crude oil is basically another name of petroleum. Or you have the natural gas. So these are natural fuels, also called as primary fuels. And from these natural fuels, we can obtain the secondary fuels, which we also call as derived fuels. Like from wood, okay, no, like from solid foods, like solid fuel, like coal, we can obtain coke from that. From petroleum, we can obtain kerosene. Getting it? From coal, we can obtain coal gas. So due to the why the processing of the natural fuels, we can obtain the secondary fuels. Okay, now by the processing of the primary fuels, we can obtain the secondary fuels. Now the question is like, why do we need fossil fuels? Also, here is the example of the fossil of a bird. That you can see the imprint of that animal have been left on this piece of rock. Getting it? Now the question is like, why do we need the fossil fuel? Does anyone think about this? Yes.
No, sir.
No. See, fossil fuels, we need them because when we burn them, we get energy now, right now, and that energy can be used to run different machines, right? Fossil fuels are required for various purposes. Fossil fuels are what? Coal, petroleum, natural gas. These are the three main fossil fuels we have. They are used for transportation, they are used for cooking, heating, even for generation of electricity. They are used for running the heavy machines in industries. They are required for launching the rockets and space vehicles. Fuels, different type of fuels are required. Getting it? So we use them for many reasons. Okay, we use them. We need them for many reasons. So fossil fuels are needed for a variety of purpose in day-to-day life. It could be transportation, cooking, industrial usage, etc. Like for transportation, okay, fuels are used to run different vehicles like cars, trucks, motorcycles, aeroplanes, trains, etc. There they are used. For cooking, they are used, right? For cooking, they are used, particularly for cooking. For instance, liquefied petroleum gas is commonly used, right? In urban areas where the firewood or coal or cattle dung is not used, so there LPG is used, right? For the purpose of heating, right now, fuel is used to generate heat. In electricity production, it is required. There we need fossil fuels, right? We know that different type of fuels are burned, like coal, petroleum, and natural gas. They are burned to create steam, and that steam is used to run the uh, it is used to run the turbines, right? And it will be further producing the electricity. Here, take a small look at this thing. See what is basically being done. We would be using different kind of fossil fuels to basically rotate the turbine. All of you first just take a look at this turbine over here. Okay, no? Take a look at the turbine here. See, we are burning some fossil fuels like coal, petroleum, or natural gas will be burned to heat the water. And after heating the water, we will see that water vapor or basically steam will be produced, right? And that steam will be made to pass over the turbine. And due to the extreme amount of pressure, the turbine is going to rotate. And as the turbine rotates, so electricity will be produced, and that electricity can be stored in a it can be stored and is and could be transmitted to the different houses via the power lines. The simple concept is such that like the turbine kind of looks like this. If you see, it will have giant blades like this. And suppose here we have basically taken a large container in which water is present. And by burning coal or petroleum or natural gas, we are going to heat the water. And as the water will boil, so it will release steam now. And via the pipes, the steam will be made to pass over the turbines. And that steam having so much of energy in it, it will rotate the turbine. And as the turbine rotates, so thereby electricity will be produced. Right now, a motor is connected. There's a motor over here with the help of which the turbine is connected, like to which turbine is connected. As the motor will rotate, so electricity will be produced, and that electricity we can store. It can be stored, and then from there it can be transmitted via the wires to the different places. Another simple thing you can understand here is that you might have done some project work where you take a DC motor, direct current motor, and you basically have connected compact disc, basically CDs to this. You have the falling setup. Okay. So you're basically trying to rotate the motor here. And on the other end, you have connected a LED bulb. So as you will rotate the motor, you can see how the bulb will glow. Getting it, everyone, so far?
I have the same thing.
You have done this. Oh, that's
Yeah,
good.
I have.
Hmm. That must be working, right?
Yes, sir.
So we basically need to rotate this motor, right? But when we are doing it on a large scale, right now, so we cannot do it manually, no, like it's a small project. But when we have to produce electricity on a large scale, so in order to rotate this motor, we have got these giant turbines, and this turbine will be rotated with the help of the steam. Steam, you understand, that is water vapor, right? With the help of steam, it is being rotated. And in order to create steam, you need to boil the water. No, to boil water, you need energy. You need to boil it. You need to burn something. So thereby, you burn natural gas, coal, and petroleum. So hope you guys are understanding it, like what we're discussing and why in electricity production fossil fuels are needed. Getting it, Farhan and everyone? Turn your camera on,
Yes, sir.
Farhan, Priyanka, turn your camera on. Then it has got industrial usage also. So there also it is used to run different machines, to run the heavy machinery. There it is used. Then one more use is in launching the rockets and other space vehicles. So rockets, rocket launch, and other space vehicles, there also it is used. So that's why we need them. Further, the question is like, what is the characteristics? What are the characteristics of a good fuel? What are the characteristics of a good fuel? You might have seen this, like in villages, particularly in rural areas, people would be burning wood or cow dung cakes, right, in order to cook the food. While they would be burning it, lots of smoke, lots of unwanted gases are being released, right now, and burning them does not produce some sufficient amount of heat also, right? So that is a bad fuel. That is not an ideal fuel. No, that is that is not the good characteristics of a fuel. So a good fuel is the one that burns properly, that is easily available in the market. It is not very expensive. It should be economical so that everyone can purchase it. It should not release poisonous gases upon burning. It should not produce large, like it should produce large amount of heat with respect to its mass. What does it mean? Means that it should produce large amount of heat with respect to its mass. It basically means that a small amount of fuel upon burning should give a large amount of heat. It's not like there's a large amount of fuel, but burning it gives only little amount of heat. So it should produce large amount of heat, like liquefied petroleum gas, right? It produces large amount of heat now with respect to its mass. Getting it? Farhan, you also turn your camera on. Okay. Then it is should have a high calorific value. About calorific value, we are going to learn in a minute. Then it should be easy to transport and handle. It should be easy to transport, like transporting it from one place to another should be easier. It should not be very bulky, right? And handling it should also be convenient. Priyanka, you're saying something?
Your voice is breaking down, sir.
Okay, do one thing, Priyanka. Keep your camera off. There might be some network issue from your side. Okay, maybe it will stabilize
Can
your
you
network.
say it?
I was saying that the good fuel, it should be easy to transport and handle also. If you have to transport it from one place to another, so it should be convenient. Like if it is too bulky, or if it is too bulky, or if it is suppose it is very flammable, okay, na? It easily catches fire, so then it is not good. Okay, na? So it should be clean and should not produce many ashes. Like when we burn it, it should not produce ashes. Like when you burn paper or wood, it produces ashes now. So it's not a good fuel. Also, it should not produce a bad odor. It should not give a bad smell when it is burnt. Then it should not ignite easily at room temperature. Like it should not catch fire easily at a room temperature. What is the room temperature? What's the normal room temperature? Like usually between 20, 25, or 30. That's the normal room temperature now, right?
Yes, sir.
So if a
Yes,
fuel
sir.
were to catch fire at 20 to 25 degrees Celsius, it's not a good fuel now, right? So it should not ignite easily at room temperature. So fuel having a very low burning temperature, it's not good. Or even if a fuel has very high burning temperature, that is also not good. Okay, no? So it should not have too low ignition temperature, and also it should not have very high ignition temperature. Very high ignition temperature. So that is the thing. Oh, give me 1 minute. I need to clear a few things. Okay. So these are the different characteristics of a good fuel. But think about this. Like, is there any fuel that has all these characteristics in it? Does any fuel exist which has got all these characteristics which we have mentioned here? Like, it is economical also. It is giving, it should be giving high amount of heat upon burning. It should not give any unwanted substance. It should be easy to carry from one place to another. So actually, there is no such thing as an ideal fuel. Okay, ideal fuel does not exist. Because, for example, if you were to consider all these points here, it should be easily available. It should not emit poisonous gas. It should not produce large. It should produce large amount of heat with respect to its mass. Basically, it should have a high calorific value. It should be easy to transport and handle. So, a fuel does not have all the characteristics. Okay, na? Although there are some fuel which is very good. There are some fuel which is very good. Okay, like for example, liquefied petroleum gas, compressed natural gas, they're very good fuel. Getting it? But it might not be economical for everyone. For the rural people, it might not be very economical. That's why they still depend upon coal and wood and some other things. Getting it now? So the thing is that there is no such thing as a ideal fuel, because ideal fuel should have all the desirable characteristics. But in the real world scenario, it's impossible to find a fuel that perfectly fulfills all the desirable characteristics, that perfectly fulfills all these characteristics, that it should have high calorific value, it should burn clean, it should be easy to transport and store, it should have it should be renewable also, right? It can be replenished naturally or over time. It should be economically um, affordable for everyone. It should be available everyone everywhere, I mean to say. It should not have any environmental impact. So that is the thing. Okay, although we have some of the fuel like say natural gas, it is close to being an ideal fuel because it has a high calorific value and it burns cleanly, but its extraction and transportation have environmental impacts. When we extract the natural gas from the ground, so it leads to some damage to the environment. Plus, its transportation is also not very easy. Talking about the hydrogen, you might have heard like liquid hydrogen is also used as a fuel now, right? Liquid hydrogen is very good fuel. Like it has a very high calorific value. Like it gives lots of heat is given out. But storing the liquid hydrogen is difficult. Transporting it safely from one place to another is difficult. And above all, the production of liquid hydrogen is very expensive. Getting what I'm trying to say? I guess you guys are not getting it. Yes, Farhan, getting it?
Yes, sir.
Okay. What about others? Keep your cameras on. Okay. So, ideal fuel is the fuel that has all the desirable characteristics. characteristics. But further, the problem is that it it's impossible to find an ideal fuel. Okay, na? Because no fuel meets all the desirable characteristics. Okay, no fuel means desirable characteristics to be called as ideal fuel. It will have some amount of limitation in it. So hope that much is clear to everyone. Next, we're going to learn about the coal. Okay. Okay, you guys tell me like what do you understand by this coal? Like how can you define coal? Mm-hmm. Yes, anyone?
Sir, can you repeat again?
How do we define coal? What exactly is it? Mm-hmm. First, we know that it's a fossil fuel,
Yes, sir.
right? It's a fossil fuel. Good. Then, what else? It's a solid fuel, right, Farhan?
Yes, sir.
It's a solid fuel. Okay. So we can
It
define
has many byproducts while obtaining.
exactly when we process it, we obtain many byproducts from it also, right? Further, we can consider this as a type of rock also, right? And what does coal mainly contain? Which element is found in it? It's the carbon. Mainly it is made up of carbon, right? Getting it? So coal, we can define it in the following manner. Like coal is a fossil fuel, right? It is a type of sedimentary rock which has high amount of carbon in it. Getting it now? Sorry. Coal is one of the fossil fuel plus it is a type of sedimentary rock and contains high amount of carbon in it. Amount of carbon in it. Then it is combustible. It is combustible and has a wide range of uses from domestic to industrial purpose. Domestic to industrial purposes. So that is the definition for the coal. Okay. Now let us understand like how this coal was formed. Like how it was formed. So coal was formed from the plant materials. Okay, now from the plant materials. What happened? Few million years ago, the plant materials, the giant plants, when they died, so they started to accumulate in the swamps. Swamps, you understand? Swamp looks like this. This is a swamp. So when millions of years ago, what happened when all these trees started to die? There might have been some natural disaster. There might have been a forest fire. There might have been some earthquake or volcanic eruption, some form of due to some form of natural disaster. They these plants started to die on a larger scale. Let's suppose, or even if they were to slowly dying and falling into the water. So over the course of millions of years ago, like roughly suppose all of this is happening 300 millions of years ago, even before the dinosaurs. So these giant plants started to die and they will slowly accumulate over one another in the swamps. Getting it, Farhan? Everyone getting it now? So they get accumulated in the swamps millions of years ago. Over the time, the plant material was buried under layers of sediment. It got buried under the layers of sediment like dirt. Hmm. And due to the accumulation of dirt over it, and later on, also oceans have started to form over it. Getting it? So the plant material here were subjected to high amount of heat and high amount of pressure. It was subjected to high amount of heat and subjected to high amount of pressure also. As they are slowly dying, they are succumbing to the lower levels and they are being subjected to high amount of heat and high amount of pressure also. Also, um, there was like as they will go deeper and deeper, so the amount of oxygen also started to decrease now, right? So under this condition, they transform into coal via a process called as carbonization. Via a process called as carbonization. Tell me if you guys are getting it this much or not. Yes, Priyanka, Abu Bakr, and Farhan, getting it? So coal is formed from the plant matter that accumulated in the swamps over millions of years ago. Okay. And that plant matter was buried under layers of sediments. It got subjected to high amount of heat and pressure, gradually transformed into coal through the process called as carbonization, which I'll be writing about. Okay. And in this process, coal actually transformed through the different stages. Okay, now like there are different types of coal also. Whether you will learn that coal based on its type is also of the different type, based on how much of carbon it contains in it. It is of different types like peat, lignite, bituminous or subbituminous. Then you have anthracite. Like that, coal can be categorized into different types. So the deeper the coal is found, the better it is. The plant remains that fair, buried deeper and deeper. So they converted into coal, particularly they converted into good quality coal. And the coal that is still above over here, suppose in this layer, the type of coal that will be found in this layer will be lower in quality in comparison to the coal that will be found in deeper layers. Getting it now? Why? Because it has been subjected to more amount of heat and pressure. The coal found at the lower depths have been subjected to more heat and pressure, hence they are of richer quality. While the coals that will be found in shallower depth in comparison to this one, so that will be of lower quality. So that is how the coals were formed. Any questions so far?
No, sir.
Farhan, you are not answering. You getting it or not?
Getting it, sir.
Getting it? Okay. Everyone keep your cameras on. Okay. So coal is a fossil fuel formed from red plants matter over millions of years due to heat and pressure. Okay. To elaborate further, it is formed. It is formed when the dead plant matters were buried under layers of sediment and subjected to high heat and pressure gradually transforming into coal through a process called as carbonization. Okay. Further, this process involved different stages. Okay, it involved different stages like peat, lignite, bituminous coal, anthracite, and eventually anthracite like that. Okay, no? So dead plant material, different type of trees, even the mosses and ferns, they also got accumulated in the swamps. They got accumulated over the time. Layers of sediment like sand, mud, etc. It has started to form over it. And under the high heat and pressure, the plant matter basically went through a series of changes. Okay, now initially there was high amount of water, like in the shallow water when they were buried. So in the initial stage, there was high amount of water content now, getting it? But as they were buried deeper and deeper, the pressure increased, the water amount in that decreased. So it converted into another form. And as they sank deeper and deeper, pressure increased, temperature increased further. So they started to convert into high grade coal. So the deeper they sank, the higher the higher quality coal they started to become. All right, no? Also, further, coal mainly contains carbon. If you were to look at the chemical composition of the coal, it mainly contains carbon, but there are some other things in it also. Also, the process of conversion of those dead plant material, of those dead vegetation into coal, in simple terms, we call that as carbonization. Right? Now, the question, where do we extract the coal from? So, obviously, we take it from a coal mine. We take it out from the coal mine. Talking about the composition of the coal. So, coal mainly contains carbon, but some other things are also present in the coal. So, coal mainly contains carbon, but some other elements are also found in it. But some other elements like hydrogen, oxygen, nitrogen, and sulfur is also found in the coal. Okay, is also found in the coal. So it's hydrogen, oxygen, nitrogen, sulfur, and the main composition, that is carbon. Okay, now so carbon is the main component of the coal, and when we burn the coal, it's usually the carbon that burns to give out energy. Okay, although the amount of hydrogen, oxygen, and nitrogen and sulfur is present in lesser quantity, then some amount of moisture may also be present. It will depend upon the type of coal you have. So some amount of moisture may also be found. Moisture is also found. Okay, now the question is like, what is coal mining? So coal mining is basically the process of extracting the coal from the earth. When we the process by which we extract the deposits of coal from the earth, that is called as coal mining. Now it can be done in the two ways. One is the surface mining here. One is the surface mining. When coal deposits are close to the surface of the earth, so large machines would be basically removing the topsoil, and some rocks also are removed. So that will expose the coal reserves, right? And then they will be simply taken out from the mountains. But if the coal reserves are found deeper under the earth, so then coal deposits are found deeper under the ground. So miners will go into the mines, like they will make vertical holes into the ground like this. They will make verticals holes into the ground like this, right? Um, uh, they will make tunnels in this also, and with the help of machines, it will be extracted. So coal mining can also be of two types. Okay, na? It is the underground mining that you're seeing here. Underground mining. And the first one is the surface mining. Surface mining. So coal mining is basically the process of extraction of coal deposits from the earth is called coal mining. Then it is of two types. One, it's the surface mining. In the surface mining, I told you, when the coal reserves are found very close to the earth's surface, then it will be done. So it is done when coal deposits are close to the surface. This type of mining is done. Second is the underground mining. So this method is done. This type of mining is done when the coal deposits are deeper under the ground. Okay, now. So it is done when coal deposits are deeper under the ground. So hope that much is clear to everyone. Okay. Any questions?
No, sir.
No, sir.
Okay. Although the extraction of the coal from the earth, it has some environmental concerns also. It has some impact on the environment also. What environmental impact can it have? Like coal mining can lead to release of so many pollutants into the earth, into the air, right? It can lead to many times methane is released from the mines, right? Now it leads to air pollution. Coal mining can also lead to water pollution also, right? Many times large, like they could be, it can lead to sinking of the land also, right? When we remove large amount of soil, rocks and coal from the ground, so it can lead to collapsing or sinking of the land also due to the removal of the, like we are removing a big deposit of coal from underground. So the land above it, the layer of the soil above it can sink down now. So those are some environmental concerns related with this. Okay. Now, based on the amount of carbon content in the coal, there are different types of coals. Based on how much of carbon is found in the coal, there are different types, right? So here it has been arranged in the increasing order. The first one is peat. It contains the lowest amount of coal on it. Coal in it, getting it? It contains the lowest amount of coal on it, and it's the poorest quality of the coal. Getting it, everyone? Peat contains lowest amount of coal in it, and peat is the poorest quality coal. So first one we have got peat. Peat will also peat contains peat contains low amount of coal, plus it contains high amount of moisture in it. Okay, now peat contains low amount of carbon in it. So it contains low carbon content. Generally, like it's around 45 to 50% of carbon content is present in the peat. Then it is characterized by high amount of moisture in it. Contains higher moisture in it in comparison to other types of coal. All right, that is the thing. Second is the lignite.
Sir,
Yeah.
sir, in the textbook, new NCRT, nothing about peat lignite is mentioned.
Okay, it is not mentioned there.
No,
Okay.
sir.
Sometimes I need to prepare, so may I leave at 8? Which paper do you are having for hand tomorrow?
English.
English. Okay. See, it's important. Like I have started this chapter, keeping in mind that you are having this chapter in your upcoming exam now.
Yes, sir.
Then, like anyway, after the class will be finished, like we have half an hour left. Can you stay for half an hour? Like,
Sir, but I have to revise every chapter. and everything.
okay. How will you cover the portion that will be left then? Mm-hmm.
Almost.
Okay. Do one thing. Stay there. Stay in the meeting for another 10 minutes, and then you can leave.
Okay, sir.
Okay, na? See. So that is the peat. It contains a lower amount of carbon in comparison to other forms of coal like lignite, bituminous, and anthracite. All right, now. Now talking about the lignite, so the carbon present in the lignite is somewhere between like 65 to 70%. So it is comparatively better quality of the coal. Now the third type of, after peat and lignite, we have got the bituminous. So bituminous has more amount of coal in comparison to all peat and lignite. So it contains bituminous contains more amount of carbon. So that is somewhere around 75 to 80% of carbon is present in it. And after this, we have got the anthracite, the purest quality of the coal we have. So anthracite contains the highest amount of carbon. So that is between 90 to 95%. 90 to 95% of carbon is present in it. So this was all that is not mentioned in the NCERT, but it's a fact that one should know that based on the based on the amount of carbon present in the coal, we can categorize them into peat, lignite, bituminous, and anthracite. These are the four different types of coal. Okay, na Farhan and Abubakar and Priyanka. So we have got peat, lignite, bituminous, and then anthracite. Now the question, like, where do we use the coal? So it has got many uses in the rural India. Even today, we see that in the rural parts of not only India, but in some other countries also, it is used as fuel to cook the food. In the thermal power plants, it is used to produce electricity. In the beginning, I told you how it is used in the thermal power plants to produce electricity. The steam will be used to rotate the blades of the turbine. In turn, that will produce electricity. It is used as fuel in different industries, right? Many years ago, it was used to run the steam powered railway engines also, right? Now, although we know that like it is no longer in use, but once steam engines were used to run the railways now, like steam powered railway engines were used, in that coal was basically being used. Getting it? Those were the early days of the railways, right? Now, particularly, it was used to power the trains in the 19th century, okay, and in the early 20th century as well. So that was about it. Now, we are going to learn about the destructive distillation of coal. See, from the coal, you can obtain different products. From the coal, you can obtain different products after some processing. Like we can obtain coke, we can obtain coal gas, and coal tar. There are three different products that we can obtain from it. So first of all, let us understand like how this method is carried on. Okay. So Farhan, you watch this video and after that you can leave the class. Okay.
Laboratory method of destructive distillation of coal. The process of heating coal in the absence of oxygen to obtain useful products is called destructive distillation of coal. When coal is heated strongly above 1000 degrees Celsius without air, it produces many byproducts. The main byproducts are coke, coal tar, amino acid liquor, coal gas. Let's understand the concept through experiment. Objective of the experiment is destructive distillation of coal. The materials required are two hard glass test tubes marked A and B, delivery tubes, clamp stand, burner, rubber stopper, pieces of coal and water. The procedure: take small pieces of coal in test tube A. Test tube A is fitted with a rubber stopper carrying a delivery tube and is clamped to the stand. Test tube B, containing water, is clamped vertically to the stand. The burner is lighted and the test tube A is heated first gently and then intensely. The gas liberated by heated coal passed through the water in the test tube B. You will observe black coal tar collected at the bottom of test tube B. The ammoniacal compounds formed will dissolve in water in test tube B to form ammonical liquor.
Oops.
Coal
There's a bird
gas,
at my
insoluble in water, escapes through the side tube. It can be lighted at the end.
Okay, see. Basically, in the industries, like coal is not used in the natural form, in the form in which it is found in the nature. Because the natural form in which the coal is found, it is not very pure. Okay, na? It has got several impurities in it. So when it will be burned, it can give so many unwanted substances. Getting what I'm trying to say? It can give so many unwanted substances. Thereby, we can process the coal, right? And after processing of the coal, we can obtain byproducts of the coal that can be used for various purposes. That is what is being done in this activity to obtain the byproducts of the coal and which can be used for different purposes. What is being done in the experiment here? This is the setup. In the setup, in this test tube, a piece of coal has been put and it is now being heated. So we have taken some pieces of coal and it is now being heated. While it will be heated, so there will be some vapor coming out of it. Those vapors will pass through this tube, and this tube is put into another tube in which we have taken some water. Okay, na? So the vapors will pass into the water, and at the bottom of the water, coal tar is formed. Coal tar is one of the component that we obtain from destructive distillation of coal. Okay. Then there is another tube over here, this L-shaped tube, from which a gas will be released. That gas can be used in the industries. Earlier, it was used for lighting the street lamps. Earlier, it was used for lighting the street lamps. And at the end, a highly porous coal in its pure form will be left. That will be called as coke. So you guys, let me resume the video from here. You guys watch it again from here.
Take small pieces of coal in test tube A. Test tube A is fitted with a rubber stopper carrying a delivery tube and is clamped to the stand. Test tube B, containing water, is clamped vertically to the stand. The burner is lighted and the test tube A is heated first gently and then intensely. The gas liberated by heated coal passed through the water in the test tube B. You will observe black coal tar collected at the bottom of test tube B. The ammonical compounds formed will dissolve in water in test tube B to form ammonical liquor. Coal gas, insoluble in water, escapes through the side tube. It can be lighted at the end of the open tube. It is a mixture of hydrogen, methane, carbon monoxide, and other gases. Solid residue left behind in the test tube A is coke. It is an almost pure form of carbon.
So that is the way how this activity is carried out. That is how destructive distillation of coal is done. We'll be learning about it further, but before that, let's do some questions from the things we have done so far. Give me 1 minute. Okay. So you guys answer one question to me. Like, which is the purest form of coal? Or rather, you tell me that, which is the highest grade coal? Your options are peat. B is anthracite. Option C, you have got lignite. Option number D, bituminous. Yes, Slam. Salman, actually, no, just wait for half an hour. Your class will resume after 30 minutes. Actually, okay, no. So on the same link, Salman, you join after 30 minutes. Like you join it at the time. Okay. Didn't you got any update from the counselor? Okay. So which is the highest grade coal from the given options? Yes, anyone? Is it bituminous coal, lignite, peat, or anthracite? Yes.
Sir,
So bituminous.
No,
it's B.
it's not bituminous.
Sir, it's B, right?
It's option number B then, anthracite. Okay, na? Anthracite
Sir,
is the highest grade coal. Huh, Priyanka?
I was saying the B.
Oh, you're saying that one. Okay. See, as I have mentioned here, na, anthracite contains carbon. About 90 to 95% of carbon is present in anthracite. So it's the highest quality coal. Okay, na? Okay, good. Further, you guys tell me, what do you understand by carbonization? What is carbonization? Yes. Next question is, from the given option, you have to tell me which one of is an example of fossil fuel. Yes. Yes, anyone? What is carbonization? We learned now that carbonization is the process by which the dead plant matters under high pressure and heat converts into coal, no? Right?
Yes, sir.
What happens here? Under high, like it's the process by which the dead plant matters under high heat and pressure converts into coal, no? Right? That is carbonization. Let me write it again. That carbonization is the process is the process in which dead plant matter under high pressure heat. Also, one more thing is there's low air in it. Okay, na? High pressure heat and absence of air, basically. Under high pressure heat and absence of air converts into coal. Okay, converts into coal. So that is what carbonization is. All right, now. Okay. Tell me which one of the following is an example of a fossil fuel from the given options.
Coal.
That is obviously coal. Good.
Coal.
How do we define fossil fuel? Define it. One another
So
question would be,
the dead
continue.
remains of living organisms.
Hmm.
Living organisms, after millions of years, it converts into fossil fuels.
Good. Another question is, why coal and petroleum are called as fossil fuel? Yes, anyone?
So what?
Second question was that coal is, yeah, this question I had given, that why coal and petroleum are called as fossil fuel. Yeah, fossil fuel we understand now. We understand that what fossil fuels are.
Yes, sir.
So why do we call them as fossil fuels? Why coal and petroleum is called as fossil fuels?
Coal is formed from dead plant matter.
Okay, what about others? Is coal formed from the dead plant matter or the dead animal matter? Or is it both?
Sir, both.
The,
Yes, Priyanka?
because they are formed by dead remains of living organism.
Exactly. So since coal and petroleum are basically dead remains of the living organisms that lived millions of years ago, that's why they're called as fossil fuel now. Good.
Yes, sir.
While coal is formed only from the dead plant matter. In the process where we had this, where we saw this image, there weren't any remains of the animals now. There are only dead remains of the plant,
Yes,
right?
sir.
So coal is only formed from the dead remains of the plant matter that were buried in the earth about 300 million years ago. When about 300 million years ago, when they were buried under the earth, they were subjected to high heat and pressure and absence of air, and they converted into coal. Okay, and the deeper they sank, the better quality coal they became. All right. Hope there should be any difficulty or doubt so far. Any questions so far from any of the things we have learned?
No, sir.
Okay. Give some examples of exhaustible natural resource and inexhaustible natural resource. Yes. Just give some examples now. Some examples of exhaustible natural resource and some examples of inexhaustible natural resource. It's simple, guys. Exhaustible natural resource. The resources that will get depleted in the nearby future, like coal, petroleum, natural gas, wildlife, huh? Wildlife, forest, they are exhaustible natural resource. And the inexhaustible natural resources are, yes, Abu Bakr, like air, water, sunlight. They are inexhaustible natural resources. In the nearby future, they are not going to get depleted. Okay. Now, this topic that coal is a source of energy. Now, as you know that coal is mainly made up of carbon. So when it is heated in air, coal burns and mainly produces carbon dioxide gas. And along with that, a lot of heat energy is also produced during that process. Okay, so coal is mainly carbon. It is mainly carbon. And when heated in air, when it is heated in air, coal burns and produces mainly carbon dioxide gas. Okay, and we can also, a lot of heat energy is given out. Lot of heat energy is given out, and you can denote this with the help of an equation. Like with the help of equation, you can denote it. So We have carbon, that is mainly carbon present in the coal. Then it will be basically reacting with the oxygen. Hold on. Oxygen from air, and as a result, it will give out carbon dioxide gas, plus lots of heat is given out. Lots of heat is given out. Okay, na? So that is the thing. Now we are going to learn about this destructive distillation of coal once again. Okay, na? See, destructive distillation of coal is basically the process where it is broken down into different components. With the help of the heat, it will be strongly heated in a closed test tube, right? And in the absence of air, it is being heated, and a number of useful products are obtained from the coal. So why the processing of the coal? By heating it in the absence of air, we obtain different products from it. Okay, just like in your previous classes, you must have learned about distillation, right now. So that distillation is the process where we, with the help of which we can separate a liquid. We can separate the two liquids. Mixture of two liquids can be separated now, right? It's a separation technique. Distillation, it's basically separation technique, right now. That is simply being used to separate liquid from a mixture. If suppose two liquids have been given to you and they boil at different temperature, right? A red colored liquid and a blue colored liquid is given to you, and you have got a mixture of the two. So if you need to separate them, so what will you do? You will heat them. So the liquid that will have a lower boiling point, it will evaporate first, and then it will go drop by drop, it will drop into this glass. The another liquid, when the heating temperature will reach the boiling point of the another liquid, right? That will also evaporate. It will go into this chamber, and drop by drop, it will also fall into another flask. So that is the distillation. It's the process where we separate the mixtures of a given component, right? So something same will be done here in the case of destructive distillation of coal also, but it is slightly different, right? Here you were actually boiling, you were heating the mixture of a liquid, but here you are basically heating a given coal under the absence of air. So we have taken a piece of coal, we have put it into this boiling tube, and the mouth of the boiling tube, in that we have put a cork, and we have fitted a tube inside this. As you will heat it, so some vapors will rise from the coke now, from the coal, I mean to say, because coal, it contains, other than carbon, it contains some amount of hydrogen, oxygen, sulfur, and nitrogen, right, Priyanka? So in the form of gas, it will start to come out, and it will go into this tube, and from this tube it will go into the water, right? It will go into the water, and it will settle down in that water in the form of coal tar. In the form of coal tar, it settles down. Now some of the component of this gas is insoluble in water. The soluble component, we have got it as coal tar, but some of the component is insoluble, and that emerges out from the water in the form of coal gas. That emerges out from the water in the form of coal gas, and this coal gas is also combustible. Like if you were to bring a matchstick near it, burn a matchstick, it will catch fire. So that is coal gas. It also has industrial use. It is used in the industries. Finally, at the end, a powdered substance is left, which is almost pure form of the carbon. Right now, it has about 95, 97, or 98% of carbon is left in this powdered coke. So it also has many uses. Getting it? So when the coal is being heated strongly in this closed structure, in this closed test tube, in the absence of air, a number of useful products are being obtained. They are namely three useful products. One is the coal gas, then you have coal tar, and you have got coke. these are all the products of coal, right? And note that these are obtained when coal is being heated in the absence of air. Okay, no? That's the thing. So the strong heating of coal in the absence of air is simply being called as destructive distillation of coal. Let me write a definition for it. The strong heating of coal in the absence of air is called destructive distillation of coal. We namely obtain three different products from it, right? We obtain three different products from it, and they are as follows: products of coal. So first one, we are obtaining coal tar, like coal gas, then coal tar, and third you have coke. Okay, third you have coke. Now we are going to learn further, like what are the uses of the three different substances that we obtain from the coal. Talking about the coke. So coke is a tough and porous black solid substance. It kind of looks like this. This is how coke looks like. This is the image of the coke. In comparison to coal, you can see how it looks like. It is tough and it is porous. Right? That porous, you understand, is something that allows the water or any liquid to pass through it. It is called as porous. We learned how it is prepared. It is prepared by heating coal in the absence of air. When the coal is being heated in the absence of air, there we saw that when it was being heated in the absence of, hold on, when it is being heated in the absence of air, so there it was being obtained, like coal gas and coal tar were eliminated and coke was left behind as the black residue in that process. Okay, so we can basically say the coal minus volatile substances from it will basically give you coke. Like if you have taken coal and from that coal you minus coal tar plus coke, so you will be left with, sorry, coal tar and coal gas I mean to write over here. If let's say that you have taken, hold on, coal, and from this you basically minus the volatile substances, like you minus coal tar plus coal gas, then you are basically left with coke. Then you are left with coke. So it's a tough, porous, and black substance. Okay, it is almost pure form of the carbon, and most important, it is used in the manufacturing of the steel and also being used in the extraction of different metals from it, their ore. So processing of coal is being done. The processing of coal to get coke yields coal gas also. Okay, now we should be learning later on. Particularly, the main thing is that in the manufacturing of steel, coke is used. We know that steel is made with the help of iron and carbon. So that carbon basically we obtain from coke. Okay. Let's do some questions from this. In the upcoming class, we'll be learning about some other components. Okay. So this destructive distillation of coal that is being done, is it being done in the presence of air or is it being done in the absence of air? The destructive distillation of coal, it's done in the presence of air or absence of air?
The presence.
Priyanka, what about you? Look at the following setup once again. In this setup, there is no air being provided to this. It's in a,
No.
okay, no? Exactly. So air is not present here. Okay. Second, you guys tell me what are the products we obtain from destructive distillation of coal? What are the three different products we obtain?
Sir, coal,
Hmm?
coal tar,
Yes. And then coal gas. Okay. Coke, coal tar, and coal gas. Okay. So from this topic, we'll be continuing in the next class. All right. In the next class, we will start from the same topic, and then we'll be learning about few more things, like what are their uses, and then we'll be starting the petroleum topic also in the next class. Okay, now. So that's it for today's class. You guys can leave. If you have any questions, let me know.
No, sir.
No, sir.
Okay, then bye everyone.
Thank you.
Yes, you're welcome.
Thank you, sir.
Yes, you're welcome.